Good day. Materials for today are this note sheet, and we're going to collect these notes for a grade. So make sure you're getting down everything that I am getting down. Alright, so congruent polygons. We've talked about that before. We've got a symbol for that. And now we're going to talk about corresponding parts. Okay, and this is a common theorem in Euclidean geometry, which is what we're studying. So let's start with a ridiculous example, shall we? So flip this over. So here's where I am going to start. Boom, right there. So hopefully you've got that. Two identical beings, we're going to call that. Alright, so that was Mary, Kate, and Ashley. Okay. So we're just going to call one Mary and one Kate for the purposes of this exercise. So I'm going to draw a wonderful picture here. Some hair. Okay. Okay. So if they're congruent, that means they're the same. And we've covered that before. Now corresponding means that the left hand of Mary corresponds with the left hand of Kate. Okay, or the right leg of Mary corresponds with the right leg of Kate. And let's say the nose of Kate would be the same as the nose of Mary. Those are all the same thing. Okay, so if I said, for example, and where this is going to go, the M corresponds with the K. So let's back that up. Let's say the left hair of Mary corresponds to the left hair of Kate. Okay, so that would be a box around them both. And let's say the first letter in Mary corresponds with the first letter in Kate. And I know they aren't perfect examples, but this is where we're going. So instead of the people, let's draw some polygons. Let's draw polygon Mary, let's draw a polygon Kate. And let's make this simple for now, so we'll draw each of the shapes same and on the same pitch and with the same slope, and we'll just go M-A-Y, K-A. Keep it all nice and in the same order. And we're going to start this by saying Mary is congruent to Kate. Okay, so what does that mean? Well, I'm very visual. I like to draw pictures, and that's a problem-solving skill. So we're going to we have our picture, we're going to add to our picture. So I'm going to say angle M is the same as angle K. I'm going to mark that with one single arc. So then I'd also say angle A, two arcs, is the same as A. I would say R is the same as T. And I would say Y is the same as E. Okay? So then we could write all that out. Angle M is congruent to angle K. Angle A is congruent to angle A. Angle R is congruent to angle T. And angle Y is congruent to angle all those things are true. Same thing with the segments. That's the same as that. This is the same as this. This is the same as this. And those things are all the same. So again, MA is congruent to KA. AR is congruent to AT. RY is congruent to TE. These are all segments. And YM is congruent to EK. Alright, so those are all the things that are congruent. Another way you can do this is just like this is the first letter, second letter, third letter, fourth letter, first, second, third, fourth. So you just match it up. You know, 1's the same as 1, 2's the same as 2, 3's the same as 3, 4's the same as 4. Same thing here. 1, 2 is the same as 1, 2. 2, 3 is the same as 2, 3. 3, 4 is the same as 3, 4. 4, 1 is the same as 4, 1. Okay? So where we're going with this is that you get the question like angle, put a congruent mark, angle T is congruent to what? And so you could look with the picture, or you can just say, hey, T is the third letter here, so it's going to be the same as R if you don't have a picture. Alright, so that's where we're going. Okay, what you guys are going to do is you are going to create your own polygon. Okay. Create your own set of congruent polygons. At least 4 sides. You're gonna name and label, and then you're gonna write congruency statements. Okay, so I'll let you guys do that. We'll go over it in class. Make sure you're doing it well, and we'll pick it up for there. So go ahead and create your own set of congruent polygons, name and label it, and then write congruency statements, just pretty much like we did here. Alright, so I just want to model some problem solving techniques that I use to do these. So do a quick model here. I guess kind of my general rule is if I have a picture, or it's easy, I'm just going to go ahead and draw a picture because I like to see things. So CGH is the same as MKR. So 1, 2, 3, 1, 2, 3. So C is the same as M. So I'm just going to do that. C is the same as M. But they're in a different spot. Well, it must be rotated. No big deal. Okay. G is the same as K. So double for G, double for K. And then H is the same as R. So triple for H, triple for R. And then I'm going to go ahead and do the sides too, since I have this part done, started. Okay. So between CG, between 1 and 2, I'm going to put 1. Between 2 and 3, I'm going to put 2. And between 3 and 1, I'm going to put 3. Okay. So now I've really done the problem. Now I just got to identify what I have in the picture. G is the same as K. CG 1 to 2 is the same as MK 1 to 2. Okay, and I can double check that here. CG 1 to 2, MK 1 to 2. G is 2, K is 2. Right? So this is just identification. Really, there's no reason to miss any of this. They've got MRK. Let me do another one. Let's do GH. Let's do GHC. So a couple different. GHC is the same as. So I go 2, 3, 1, and I'm talking about these now. So 2 is the K. The 3 is the R, and the 1 is the M. Okay, now let's double check that. G is 2, K, H is 3, R is 3, C is 1, M is 1. And then also look over here. GHC goes 2, 3, 1, K, R, M goes 2, 3, 1. Awesome. Okay. Now when I have kind of a longer one, or I don't have a picture, I might just use the lettering or the numbering system. So I'll just go 1, 2, 3, 4, 5. Okay. So like F is 3, J is 3. JE is 3, 2. FC is 3, 2. Segment. Alright. If you want, you can draw a picture. You can choose any shape you want, as long as it has, 5 vertices. So you could draw that out. 1. So it could be A, C, F, R, Q, and you could do the same thing over here if you wanted to see. Yeah, it's up to you. I'm gonna jump down to 5. So CV bisects this TC, W, and TV. So bisect means it's going to cut this in half. That means those are the same, and then it also means that those are the same. Okay, so I might draw 2 separate ones just to really see it. TVC, VWC, those are the same. It's the same. That's right angle. That's right angle. Same. Okay, so TVC is the same as, so we go right to 1, WVC. Okay, and we go W, and we go WCV, right 1, 2 is TCV. CV is obviously the same as, and VC